good evening. We are Srineha and Sri Lakshmi from Data Science C section from Institute of Aeronautical Engineering. The subject is data structures, and our topic is quiz scoring systems using binary trees. So, quiz scoring systems are essential for to evaluate the participant performance. So when the participants actually perform, the scoring system, it evaluates how they perform. So therefore, that is very essential, and they provide a structured way to access knowledge and skills in a given subject. So various data structures, including binary tree, can enhance the efficiency of this system. So there are types of scoring systems. There are many, but quiz scoring system is one way to evaluate participants' performance. A binary tree is a data structure where each node has at most 2 children. A perfect binary tree will have exactly every node will have exactly 2 children except for the leaf nodes. They'll have zero child. The binary tree provides a hierarchical organization that can efficiently manage quiz data. Binary trees are particularly used for searching and sorting quiz scores. So yeah, the structure of the binary tree for quiz scores. Each node each node in the tree represents a quiz score associated with the participant. Nodes can be organized based on score values to facilitate quick retrieval. And the left child node typically contains scores that are lower than the parent node, and the right child node contains the higher scores. Insertion of scores into binary tree is inserting a new score involves traversing the tree to find the appropriate position. The algorithm compares the new score with the current node score during traversal, and once the correct position is found, the new score is added. And binary tree, we use it for efficient data management and organized storage. Binary tree provides an efficient way to store and retrieve questions based on a unique key. And the average time complexity for binary search for insertion and deletion is O log n. And other reasons why we use binary trees is because of scalability. The core components of systems are nodes, tree structure. Nodes can have the question ID or question text or options or the correct answer or the left and right pointers that are linked to the child nodes. The tree structure, the root node can serve as the starting point, and the left subtree will have smaller keys and the right subtree will have larger keys. Operations in this quiz storing system can be insertion, search, and deletion. New questions are inserted into the tree based on their keys. If the key is smaller than the current node's key, it will go to the left, and vice versa. If it is larger, it will go to the right. In traversal, there might be in-order traversal, pre-order traversal, and post-order traversal. And the advantages of this binary tree in the quiz might be it will have fast access and dynamic structure and flexibility in traversal. The searching for a question by its ID or key is fast compared to linear structure like a list. So in binary, you can have a faster method, faster way to access the questions. And the tree can adapt as many questions, or you can add or remove as many questions as possible, since it has a dynamic structure, and it is very flexible because it has various traversal methods like in order or pre-order. So there are different ways of presenting the stored questions. There might be certain challenges like balancing. So in an unbalanced tree, time complexity might vary, and insertion and deletion can degrade to the worst case ON, or maintenance overhead. So deletion and rebalancing operations can be complex, and especially for larger data sets. So limited functionality as well, that is another challenge, that is limited functionality. A binary tree structure is ideal for hierarchical storage, but might need extension to handle complex quiz data like multimedia content. There might be some extensions for this binary tree. You can use AVL or red-black trees, or you can use persistent storage. for long-term storage and retrieval, or you can use integrated AI so that it can have a better performance. Yeah. So
Searching the scores, searching for a specific score begins at the root node of the tree. The search process follows the binary tree rules, comparing values to navigate left or right. This method significantly reduces the average search time compared to linear data structures. Linear data structures are arrays, stack, queue, and linked list, and nonlinear data structures are graphs and trees. Deleting scores from the binary tree. Deleting a score requires identifying the node to be removed and its position. There are three cases to consider: removing a leaf node, a node with one child, or a node with two children. Proper restricting of the tree is necessary to maintain its integrity post deletion. Traversing the binary tree. Traversal methods includes in-order, pre-order, and post-order techniques. In-order traversal is partially useful for retrieving scores in ascending order. Each traversal method serves different purposes based on their desired output format. Advantages of the using binary trees for quiz scoring. You can assign specific scores to paths. The binary structure allows quick traversal. Easily add or modify the questions and the scores. The applications personality test, adaptive quizzes, scoring system where each system impacts subsequent ones. The detailed structure of the binary tree. The question or the prompt for the user. Options are the possible answers such as true or false or multiple choice. The score points awarded for the specific answer. Children like to subsequent questions based on their users' answers. Breakdown scoring the path example. Question 1 is Python a programming language? The answer is yes. So move to the question 3. Scoring logic. Correct answers leads to the right subtree, higher scores. Incorrect answers lead to the left C, which are lower scores. Leaf nodes represents the final score for a given path. There are more advantages. They are dynamic scoring. Scores are determined based on the path taken. Personalization. Add different questions for each subtree. Efficiency. A balanced binary tree minimizes the question of the number of the questions asked. The real world applications are adaptive learning systems, knowledge-based assessments, gaming systems. Example RPG skill trees. The binary trees provide efficient insertion, deletion, and search operations. They can dynamically adjust to accommodate scores from multiple quizzes. The hierarchical structure allows for easy and categorization and retrieval of scores. The challenges and considerations. Balancing the binary tree is crucial to maintain optimal performance. Unbalanced trees can lead to increased search times, resembling linked list. Implementation self-balancing trees like AVL or red-black trees and mitigate performance issues.
Theoretical applications in a quiz system can be efficient quiz management, quickly search for questions by ID or topic, so we can search quickly based on the ID and organize the questions dynamically. We can another application for quiz system can be hierarchical organization. So these questions can be organized based on topic or subtopic in the near nested manner, and you can use a binary tree. A binary tree is used as in a in-memory representation of a quiz database for faster operations. Some practical use cases can be learning management systems, like store and retrieve questions, quiz questions dynamically based on course modules or difficulty. Game-based quizzes, like you can select the difficulty as the player progresses, or performance analytics. You can use the tree structure to group the questions by performances, such as accuracy or time taken to answer. And you can use more, you create more tools so that you can provide the educators with an efficient system to manage and organize a large pool of questions. This is the code for the This is the code for the quiz using binary search. We use Java for it.
Let us execute this code. Here you can see there are the options like adding, insertion. Second option is searching for a user, that is searching. Deleting a user, that is deletion. And display the leaderboard and the exit. So now let us enter the choice. First choice, that is insertion. Now I'm giving a name like Sri Lakshmi, and I'm entering the score 90. Then it asks for the second choice. Let us give another insertion 1, naming it as Neha, and score it like 80. Again it shows another choice. Now we are inserting another name, choice number 1, that is adding a new user. New user name, let us give it as data, and scoring it 50. Now let us see the display board. Now let us delete a user. For example, for deleting a user, we use 3, that is delete a user. So I'm deleting. Enter the name to delete. Suppose I'm deleting data. So user data is detected. Now let us see the display leaderboard. That is user 4. So now you can see the leaderboard. That is Neha with 80 and Sri Lakshmi with 90. Now I am entering the choice 5, exiting the system. So this is the execution of the binary search tree using a quiz scoring code. Thank you.
Thank you.